All right, guys, here we go. This is the review for the very first part of our quiz, points, lines, and planes. I'm going to work through this so that you have some help on it. Here we go. First question, it says if B is the midpoint of AC, so we don't know where coordinate C is. We're looking for coordinate C. Find the coordinates of C. So we don't know where it is. The way that I kind of showed you guys is take the coordinates like 2, 5, that's coordinate A. And then the coordinates for B, -2, 15. And ask yourself, what is delta x? Like how far is that? Well, that is -4. So if it's -4 to get to the middle, you have to do another -4 to get to the other side. Same thing with the y values. That is +10 to get to the middle, and so it takes another +10 to get to the other side. So that has to be -6, 25. Check your work. What is 25 plus 5? 25 plus 5 divided by 2 is 15. Over here, 2 minus 6 divided by 2 is -2. So we know that if B is the midpoint, that C would have to have those coordinates. Very well done. A and B again, it says Q is 1/4 the distance from A to B. So similar idea, we need to know our delta X and our delta Y. To go from 2 to -2, that is -4. So if we know that delta X equals -4, and we want to go 1/4 of that, we need to do 1/4 of -4, which is -1. Now that's the delta. That's the delta. That's how far we're moving. That is not the answer. Most common wrong thing people do is they say that's the answer. To get the answer, you need to take your starting position and you need to apply the distance. Apply the delta. I want to put delta there, it's easier. Starting position, apply the delta. Well, for the x's, your starting position, where are we starting? We're starting at x equals 2. So we're starting at 2, and we're doing -1. So our new x coordinate is 2 minus 1, which is 1. And then we're going to do all the same work for the y values. The y values are +10. So delta y is +10. And we want to do 1/4 of 10, which is the same as 10/4, which is the same as 5/2, which is the same as 2.5. And so we're going to do the same thing. We're going to do our starting value, or for the y values, our starting value is 5. So our start is 5, and we're going to apply the new delta 2.5, and we're going to land at 7.5. You may type the answer as a decimal or the fraction. So that's going to be 7.5. There's your answer, 1, 7.5. Perfect. Next question is a true or false. A, B, and C are coplanar. True. I didn't even look at the picture. Don't need a picture. 3 points are always coplanar, but A, B, and C are on a line, so they actually are hit by infinite planes. In this picture alone, they're on the left side and on the back side. So in this picture alone, there's 2 planes that hit them, but infinite planes hit them. A, B, and C determine a plane. That's false, just for the exact same reason we just talked about. They're in a line. To determine a plane, you need to make a triangle. If you make a triangle, only one plane hits you. If you're in a line, infinite planes hit you. False. H, B, and M are coplanar. Do not need a picture. Same thing, but let's just, for giggles, let's look. H, B, and M make a triangle, and yes, they're coplanar. That plane is not drawn. That plane would slice through the pyramid at a different angle, and it would go through the pyramid. It would not be one of the existing planes. But they make a triangle, so they do make they're on a plane together, exactly one. J and E are collinear. True. I don't need a picture. But just for giggles, here's E, here's J, and here we go. I can draw a line from J to E. Guys, to be non-collinear, I would need at least a third point. right? 2 points are always collinear. 3 points are always coplanar. To be non-coplanar, you need at least a fourth point. This plane, JML, let's figure out where JML is. Here's JML. Well, all of those points are on the bottom. This triangle, if you were to expand that triangle forever, you're making the bottom of this pyramid, right? All of those are on the bottom together. So that means every point on the bottom is going to be with JML. Well, is F on the bottom? Yes, true. F is on the bottom. Now, if it had said A, B, C, D, or E, A, B, C, D, or E, all of those are above the bottom. None of those are on the bottom with J, M, and L. So you have to be able to picture the fact that these are on the bottom together, and then all the other points on the bottom, they're all on a single flat surface together. F is on the bottom, so the answer is true. KEA, let's find it. Here's K. Here's E, and here's A. That triangle, those points are on the back plane together. And I'm going to highlight that in bold, but that is the back of this pyramid. So we have boop, boop, boop. All of that is the back plane, and that has K, A, B, C, D, E, F, and L all on the back. And L is one of those, so that is true once again. If it was any of these points in front of the back, we would have had to say false, but all of those points are on the back of that pyramid together. Next question is, I don't know what all these are. Let's look at these. Lots of choices, so let's read them. What is the intersection of two lines? Two lines intersect at a point. I don't need options, I know. What is the intersection of two planes? Two planes intersect to form a line. Name the intersection of plane AKL. Let's find AKL. AKL. Those would be this plane. Those are on the back plane together. And JKL, let's find that one. JKL. JKL would be the bottom plane. So if I want to name that intersection, it would be this line, KL, or KF, or LF. It doesn't matter what you pick. To name a line, you pick any two letters on the line. Let's see if it's any of these. KL, KF, LF. Here I see KL. There it is. That's the one we're going to use. Line KL. Line symbol KL. Name the intersection of those two lines. Let's clean it up so we can figure it out. Two lines are going to hit at a point. We know we're looking for a single point of intersection. So we have KG. KG is this bad boy right here. And we have HF. HF is its friend over here, and where do those two lines hit? They hit at point G, and I know that's a single capital G to answer that question. An example of 4 non-coplanar points. Well, there's lots of options. We need to look at the actual choices here. There's 4 points, there's 4 points. It's got to be, there's 4 points. It's got to be one of those, so let's look. We want them to be non-coplanar, so not flat. AKMG, AKMG, let's look. AKMG, yes, KMG is a line, AKMG, those are going to be coplanar. That is not it. So remember that if you keep listing points in a line, the next point will always be coplanar. But yes, KMG a line, A off the line, that's a single plane, that's a triangle. So that's not it. So it's not AK, nope. It's KMLF, let's find it. Let's see here. K, M, L, and F are all on the bottom together. M is on the bottom, K, L, F. Once again, K, L, F are a line. So I could have said any point in the universe. It doesn't matter because K, L, F are in a line. It didn't matter where M was, but they're all on the bottom together. So K, M, L, and F, not it. So it better be this one. K, M, J, A, K, M, J. Those are on the bottom together. So that's this surface, and A is above the bottom, so it's got to be that one. So out of our choices, it has to be that one. K, M, J, A is the only one that actually works there. Perfect, beautiful. And then the next, it says an example of 3 non-collinear points. Let's see what our choices could possibly be. We're looking for 3 points. It might be KLF, ABF, LMH. Those look like those are the choices. And they need to be non-collinear. So let's do this quickly. LMH, that's a line, so it's not that one. KLF, KLF, that's a line, so it's not that one. So it better be ABF, or in big trub. ABF, perfect, non-collinear, those make a triangle. So out of our options, it had to be ABF. And then how many planes contain D and F? Infinite. Don't need a picture, don't care, that's a line. How many planes hit a line? The answer is infinite. Perfect. Question number 10, I got 2 points. If N is the midpoint of Mo, so here's M, here's N, and we're looking for O, find the coordinates of O. Well, we did this one earlier, same exact thing. So we have 2, 10, that's point M. We have 22, -5, that's N, and we're looking for the other side O. So 2 to 22 is plus 20, so we're going to do another plus 20, land at 42. This is minus 15. We're going to do another minus 15. And that's going to land us at negative 20. And we got our answer, 42, -20. Boom. All right, N is the midpoint of MO. Yep, got it. Perfect. We have 2 coordinates. This time we're 3/4 the distance. It says P is 3/4 the distance from M to N. So, same as before, delta X. Look at the X's. 2 to 22 is plus 20. So I want to do 3/4 of 20. And that would be 5 times 3. That's going to be 15. So remember we talked about good math. People that are really good at math are going to reduce, make that 5. And then 5 times 3 is 15. So that's plus 15. That's not the answer. We're starting at 2. So it's 2 plus 15 is 17. So the first part of our coordinate has got to be 17. 3/4 of the way. And then delta y is going to equal 10 to -5. So that's negative 15, just like we did a second ago. We want to do 3/4 times negative 15. That does not reduce. So that's going to be 45, negative 45 over 4. Which is going to be a negative 11.25 if we want to think of the fraction. That's not the answer. We have to start at 10. So if we start at 10, we do minus 11.25. We end up at negative 1.25. So it is 17, negative 1.25. Nailed it. It says you may type the decimal or the fraction. So there you go. So we can leave it as just negative 1.25 if we want. That'd be negative 5/4 if we were writing the fraction. Okay, I'm feeling pretty good about that. Plus 20, that'd be 15, 17, nice. Minus 15. Minus 15 would be 11.25. Perfect. I like it. All right. Well, last question. Darn it, we're already on the last question. Too easy. If 3 points are coplanar, they determine a plane sometimes. If they're in a triangle, yes. If they're in a line, no. 4 they're non-collinear points are coplanar. If they're 4 non-collinear points, they do not have to be coplanar. 1, 2, 3, 4, yes. But if we had this point somewhere else off the surface, the answer is now no. You can measure the length of a line, never. You can measure the length of a line segment. That's really picky. I'm usually not that picky, but that one's pretty picky. Lines go forever. You can't measure the length of forever. If 5 points are collinear and the 6th point is not on that line, 1, 2, 3, 4, 5, then all 6 points are coplanar, always. A line and a point off a line is always coplanar. 2 points are coplanar, always. 2 points are collinear, always. The intersection of 2 planes is a point, never. All right. 2 points make a line, infinite planes hit a line. 2 points make a line, they're collinear. And then the intersection of 2 planes is a line, not a point. All right, crew. That is the end of this review. Some tough questions in there. Make sure you know what you're doing. Don't just copy answers. Make sure you're understanding what we're talking about. Love y'all. See y'all next time.